Hey, Dr. Shank, I got a question about the extra credit for
Yeah.
classes. So is just like the paragraph on the presentations or like the power? I mean, I guess the posters are going to be somewhat of
Yeah.
presentation as well, but
Yeah. I mean, it's just like a reflection on what was interesting, whatever, for each thing that you go to
okay.
or that that you look at, obviously.
Right.
Yeah, it's a little strange thing. I wish they had done it like synchronously.
Yeah. The only thing that I kind of like about it is that I'm communicating back and forth with Soika about like what like needs to be in my PowerPoint and so forth.
Yeah.
And I'm gonna send her like multiple recordings.
Oh yeah. So she can be like, oh yeah, don't do this or whatever. Yeah, that's good. Yeah, that is good.
Just so like so we had like PowerPoint is like getting there, but like
Yeah.
the recording is what I mean, I have a script, but like I typed one up for when I was presenting in senior research and I like didn't use it. So I talked for
Right.
like 30 minutes, didn't use a script. So
Yeah.
I almost feel like winging it is going to be better off for me and then just like do that a couple times and then kind of pick the best one.
It's often the case. I mean, we always, recommend, pretty much anyone will recommend to you that you don't memorize talks.
Yeah.
But that's a special skill to be able to get up there and not, forget what you want to say or, say a million times.
Yeah.
Yeah.
And the topic that I'm doing is like I'm really familiar with. I
Yeah.
have so much background about it, so that really helps me.
Yeah.
Instead of like doing something like modeling bacteria growth,
Right.
what I'm doing is I'm very familiar with it, and it's very like
That's really good. Yeah, that's the best place to be in when you're talking about something. Yeah. Hello, Zoe. Are you at home or are you in Randolph?
I'm at Randolph.
How is it over there? I mean, I've been on campus, but how's it for you?
Dead.
Dead.
I had a big bee. It was crawling on the floor outside my dorm, and I was like, oh, it's not going to come in my dorm room.
Right.
It crawls under my door.
No!
That thing, I kid you not, was this big.
Yeah, those big black bumblebees.
Yes, and I didn't know what to do, and then it started like buzzing and flying everywhere, and I started freaking out, and I was screaming because I didn't know what to do and how to get it out. And then it like landed near my fridge, and I thought it went in my cereal box. Like it was open. Like I was trying to pick up my cereal box and not make it mad, and then I dropped it down the stairs, and But then it turns out I couldn't find it, and then I opened my fridge later that night, and he's sitting right there looking at me.
Oh.
And then he tried to oh my god, it was a mess. I ended up having to kill him because I didn't know what to do. And he was like buzzing really loud. It was very dramatic.
Oh, I'm so sorry. Those big bees don't sting, right?
I know. I was trying to pick him up to like get him out, and I accidentally squished him. So
no.
I accidentally squished him the rest of the way, so he wasn't like half dead.
I got you. Yeah, they're not the brightest of bees.
He kept flying into like the blinds, like headbutting, and I don't even know. I felt
Yep. I saved one the other day because it was in here and my cat was about to like
paw it.
Yeah. But they're just so dumb and big, and so I was just like, I put a cup over him and like, got him outside. But
I think he was like special to begin with because he wasn't flying a lot. Like he was walking a lot. That's what
walking a lot, yeah.
Because, like, I walked down the hall, and I thought it was a big cockroach at first because he was just walking, and I was like, this isn't about to happen. That's why I didn't kill him at first, and he crawled in my room.
Oh, I'm sorry.
Oh, my God. That was me in the bathrooms in Maine because every once in a while there would be a cockroach that just ran under my toilet, and I'm like, nope.
No, I hate that.
I was in the garage last weekend and I found there was like a wolf spider sitting on like a rag on a toolbox, and I kid you not, it was like this big. It was 2 to 3 inches in diameter.
Dang, do those bite?
No, I've seen them crawl on like. There was a guy that when we like went for orientation, we went to like a paintball place.
Yeah.
Like this guy like would let them crawl on him, and he would like feed them and stuff. It was super weird. I don't know. I just got the blowtorch and I was like, screw that.
It was like the second day of me being in the dorm, like all the way at the beginning of the year, and a spider bit my neck.
Oh!
I was laying in my bed, and then something bit me. I was like, ow! And then I picked it. I was like, oh my god, it's a spider! It was like 12 o'clock at night, and I called my mom freaking out. I was like, Mom, a spider just bit me. This is
Oh,
weird.
that's the worst. Oh,
But it was just like
God.
one of those like normal spiders you always
Yeah.
can ones or whatever. I don't even know what they are,
Yeah.
but I hate
I hate bugs. I do.
I do too.
Well, guys, we should probably get started. Who would like to go first? Okay.
I can volunteer as tribute.
Okay, let's do it.
All right. So I can just share screen.
Yeah. Oh, let me, sorry, I always forget to make it so you can do that. Okay, go.
All right. Can everybody see?
Not yet.
We're all good?
Not yet.
Okay. It clicked. Oh, here we go. There we go.
There we go.
Let me put everybody in the middle. Now I can't like see what I'm looking at.
Yeah.
Okay. All right. So I had this problem, and so first off, I found out.
You might want to read the problem a little bit so that people can see, like read it off to them.
My job was to find the proportionality constant of K, and then using the stationary state of the quartic oscillator given by this. And I actually had to do a little bit of research and find out that I didn't really have to use, the quartic oscillator or the virial type things going on. And it was fun to learn about those things. And it was fun to kind of discover the path forward through this problem. So let's jump into it. So we laid out our initial conditions, and we know from earlier in the book that so this is a time derivative, and then the x hat would be the stationary state. So we know from earlier that the time derivative of the stationary state is equal to 0. So we can just set the entire equation to 0 and then start to plug in, the, K for t or K of v for t. And then we can start to plug in v of x for those
Excuse me.
distinct variables. So we plug those in, and then we take the derivative of this based off of that. And then we get, these two are here. And so the m alpha x to the fourth, that should be an alpha squared. I don't know why, I just didn't write it down, I guess. But these cancel, and with the equation equal to 0, we can then solve for k, and then have k equal to 2. So.
Okay, any questions before I give comments? Questions? Okay, John, a couple comments. So if you go up to your beginning of your thing, so just to be aware that what's going on here, right? So x is not the stationary state. So what's happening is size, right?
Right.
For the quartic oscillator, let's say quartic, is stated as these are stationary states.
Mm-hmm.
Because they are, it tells you in the problem anyway that they are. And what that means is that the time derivative of any expectation value, no matter what's inside here,
mm-hmm.
no matter what is in here, it can be x squared p to the 10,000 or
mm-hmm.
p to the 20,000 over x times something, right? I mean, anything that's in here. The time derivative of any expectation is 0.
Okay.
Right? So this meaning that, remember the expectation value is an average, right?
Absolutely.
That's saying that average doesn't change with time. No matter what you put, no matter what you're taking the average of,
mm-hmm.
that doesn't change. You could measure it 1,000,000 times, and at any time t, and you'll get exactly the same average. So that's what it's saying. So be careful about that. And then if you come down here, I'm a little confused about what is this? Let me get rid of my drawing so that you can see. Okay, what is this? Because it looks like,
Oh, that's the DVDX. That's just showing I need to take the derivative of this little thing right here.
oh, okay. I'm a little confused by your notation,
It
right?
didn't, yeah.
Oh, okay, because it probably would have been like something like dm alpha squared x to the fourth dx, right?
Yeah,
Because you're taking the derivative of all
that would be.
Okay. That was confusing there. Okay. Other than that, good.
Okay.
Okay.
Do you want me to kind of tidy up? I mean,
Sure, tidy it up. That would be good. And explain this a little bit more the way that I explained it, or
Okay.
the way that you understand it now, hopefully. And then, because then then I can give you like full credit.
okay. Do you want me to do that now or
Yeah,
wait?
well, you could do it and then turn it into me
Okay.
by email. That's fine.
I'll just type you up
Yeah,
something about that.
sounds good. Yeah.
All right, sounds good. And
Yeah.
I'll like rescan this and kind of bold out some of the things that
That'd be good. Yes.
All right.
All right. Next.
Go back to Zoom. Or a minute. Okay. There
Now
we
you
go.
gotta stop sharing it. There you go. There you go.
I guess I can.
Okay. Cool. You sound excited.
I don't know if I'm right, but I guess we shall.
Mm-hmm.
So how do you do? Can I just do like? Because
Screen
I
share?
uploaded it to my photos, or do I do like the whole desktop?
Either way,
Okay.
I like to do the whole desktop. It's a little easier sometimes.
Can you guys see that?
Yeah, it's a little blurry.
Is it? Wait, hold on. Let
Yeah.
me see if I can.
There, it's a little better. Yeah.
Those are all my pictures. Sorry.
I
guys.
know. I see. That's a downside.
Hold on. We don't need all of those being seen.
Kitty. Sorry, I gotta move the cat into the sun. There we go. There we go, Kitty. We're not in the sun?
Well, okay. All of it's ELAB pictures, so it doesn't really matter.
Yeah, it's not.
ELAB pictures and yeah. Okay.
Okay.
Okay. So is this better?
Yes.
Okay. So my problem was to prove that if you add a constant V naught to a potential energy function of V of x, the energies for the system shift from E to E plus V naught, and then the solutions of psi remain the same.
Mm-hmm.
And so this was my work. I started with just, like the general TISE function, and then I plugged V. Can you guys see my mouse? I don't know.
Yeah, we totally can.
Okay. And then I plugged V plus V naught into the V of x function, or the V of x, and then I distributed the psi into it,
Mm-hmm.
and then I pulled the psi's out to show E equals E plus V naught.
Yeah.
Because the whole chunk here
Yeah.
equals the original E of psi. Yeah. And then why the psi doesn't change is because the energy that's added is not dependent on the x values, because it said it's just a constant it was given in the problem. So once you put psi into any system, it will just disappear.
Right.
Okay.
Good. Yeah, no, this is good.
Okay.
Yeah. Good. Yeah, if you want, you can, you're going to get 100% on that because they did it right. So
Okay.
yeah.
I just didn't know if I had to show anything for the psi. I couldn't think of how to show that other than doing a huge integral like this. But I didn't know if you wanted me to do that.
No, it doesn't. It's not necessary.
Okay, so I explained it okay?
Yeah, you're fine.
Okay, cool.
Good. Any questions from anyone else? No? Okay, good. Yay.
All right, how do I stop sharing?
There should be like a red stop share thing on your thing. There you go.
Thank you.
Sure. Who's next?
I can go, I guess.
Okay.
Okay, where is your screen? I love having to go into my system preferences and allowing all this stuff.
No. Shouldn't have to do all that.
It says I have to quit Zoom to allow it. My security stuff says I have to quit Zoom before I can allow it.
That is.
So I'll have to get back in.
Well, why don't you try that? I hope that's No,
Okay.
that's crazy. I've never heard about that. I'll give you a second. So I think we'll just end class when everyone's done. Just take a little break. That cool? And then, because usually on a test day, you know, this isn't really a test, but you know, we wouldn't have a lecture and a test, right?
So when is the extra credit due?
I'll accept things up until the end of finals week, just not official.
Okay.
You know?
Okay. I just wasn't. So is that gonna be towards what? Like, just like extra, like.
It's like it would be added to your total grade at the end.
Okay.
Yeah.
Jeff is like, yes.
Yay. Okay, here we go.
Okay,
Great.
I was muted. Okay. So I have two. That's not what I wanted. There we go. So I had two pictures of stuff. I wasn't exactly 100% sure on what to do. But I had the question that's over here. I had to consider the solutions to the time-independent Schrodinger equation given by psi n with discrete energies En. The total initial wave function for the system with those solutions was given by psi x0 equals 1 over root 5 psi 2 plus 2 over root 5 psi 5. I realize my video is off. Does that matter at all?
What video off? No, it doesn't matter.
Okay. All right, I found it. So 2 plus 2 over root 5 times psi 5. And then I had to calculate the expectation Hamiltonian for the wave function, and I could leave my answer in terms of E. So I wasn't 100% sure, but I went over here and I had plugged it in to the equation with the integral from negative infinity to positive infinity with psi star, the Hamiltonian psi dx, and then I plugged it in. I wasn't sure from there if because the Hamiltonian psi equals E psi, if this would technically equal E psi, and then because the psi's are equal, if it would just be E at the end for the energy because the psi's in the total psi solution are the same.
Any comments or questions from you guys before I give comments? Zoe, you look skeptical. What's up there? What are you thinking?
I'm just trying to, because she said she wasn't sure if how she ended it, if psi 2 and psi 2 would be just E because they're equal, and I'm just trying to go through it in my head and try to help her if I could.
So, do you want to say more, or anyone else? Okay. So Aaron, the thing here is that there's like a bunch more steps that you could do, right? So if you think about it, the Hamiltonian has to get applied to each of these terms, right? And you're right. So let's back up just a tiny bit, because over here and here you have written down the energy, but what you have the energy for is the infinite square well.
Okay.
And this isn't no one said this was the infinite square well, so you don't even have to worry about that. You can just call things like E1, E2, E3, right? So this is not, you don't want that. This is correct, but when you talk about applying a Hamiltonian to, like, say, side 2, you expect to get E2 back.
Okay.
Right? So when you apply the Hamiltonian to this, what should you get?
That would be E2 and E5.
Right, so you get E2 over what?
Would it be over root 5?
Yep, and then plus 2, E5 over root 5, right? And then you need to evaluate the integral. So what do we know about the integrals of, solutions to the TISE if, something like psi star 2, psi star 2?
It's going to be 1. Because they've got the same.
The integral psi star 2, not psi star, that shouldn't be a star, sorry about that. Psi 5.
That's going to be 0.
Yeah, so you could just distribute these out, right? Pull the e's out
Yeah.
of the integral and finish up. Okay, so
Okay.
that's what you should do, and then turn that in.
Okay.
Okay? And
Yep.
your answer will be in terms of like, things like E2, E5, whatever, right?
Okay.
Yeah, but no integrals will be left.
All right.
Got it?
Got it. Thank
Okay.
you.
Sure. Okay. Next. There's only
Is that
one
open?
left.
All right. Can y'all see that?
Yeah.
Okay, so my problem was to calculate the commutators for each of these. And first, going over here, I found these from what we did in class and from what I found in the book.
Mm-hmm.
I don't know if you can see, because I got
Yeah.
it right over here.
Yeah.
And I kind of just applied it to these, working with p squared, and ended up with 2 bar p.
Okay. Cool.
Moving on to x squared, I applied the same process and got 2 bar x.
Mm-hmm.
For x squared and p squared, I kind of had to do it twice,
Mm-hmm.
moving through.
Mm-hmm.
And I got 2 bar xp minus px.
Mm-hmm.
And then going down into the Hamiltonian and momentum, I had to go through. I broke it up from this first part, p squared over 2m,
Yeah.
and v of x, and I broke them down. And for p squared p, I kind of worked it out over here, and I got 0 for the first term, I guess.
Mm-hmm.
So I just focused on the v of xp, and I applied it on like a random side, like it doesn't mean
Yeah.
anything.
Yeah.
And working it out down here with the derivative, I got IH bar
Yeah.
dv dx, and I took out the psi because it didn't mean anything.
Yeah. Right.
And then moving back into Hamiltonian momentum squared, I applied the same process that I did from x at p squared, just using the Hamiltonian instead of x, and got 2 bar p dv dx.
Okay, so be careful because P. Remember, P is an operator, right?
Right.
Okay. Any comments before I go on to make comments? No. Okay. Cool. All right. So can you scroll up? Just to right here. Okay. So right here, right? Let me annotate. Sorry, I didn't turn on my annotation. So right here, this is the commutator XP.
Okay.
Like IH bar, right? Or
Oh,
something.
so I could have kept going and
Yeah, so you could have kept going. So that was something you want to do.
okay.
Here, whenever you're putting a psi on, you want to like redo this side of the equation just because you want to say like, oh, now I'm applying my commutator to psi equals this.
Okay.
It's just a form that you want to make sure that everyone's clear that now you're applying this to psi as a way of figuring stuff out. And then in the end, you get rid of it, right, like you did. Right? Just to be clear. And come down now again. And then here, you want to make sure that you're applying P, right?
Right.
Because P is like H bar over I ddx or something, right?
Yeah.
P hat, I'm pretty sure. I always forget if it's minus H bar over I or H bar over I.
Minus H.
Yeah. And then you can, apply that, right? Makes sense? So if you make those changes.
I gotcha.
Okay, cool. Good.
Yeah.
All right, guys. Well, good job, everybody. You got to, either very, very close to the correct answer or the correct answer. So that's good. So just get those corrections. Those of you who I told to do sort of corrections or expounding a little bit more to me by email. And we're good. Now I just don't know what happened to Dylan.
When do you want those corrections, or?
You can give them any time between now and the end of finals week, but really I would do it now so you remember what I just said. right?
Absolutely.
You could look at the recording, obviously,
Mhm.
but
There's no like hard deadline.
no, I mean, but like I said, just before I have to grade stuff, and for seniors like yourself, I have to grade. I have to get stuff in pretty quickly after the end of finals week.
Okay. I'll probably get them to you today, but just
Oh yeah, cool. Yeah, I would do it while it's fresh in their head,
so,
right? Yeah. Okay.
so-
All right. Well, we can end class early, a little break before MATLAB. Although MATLAB is really office hours, so who knows what's going on in that? We'll see. We'll see who shows up for the office hours.
All right. We'll see you Friday.